Hello friends, welcome to Susan and John MathTube. This is lesson number 23 in the examination preparation series for the first year engineering students. And in today's video, we are going to learn something important in differentiation under the integral sign. So as always, the most important question and the 5 important points. Hope you're doing all these things, and let's start with the first question. And the first question is, evaluate the integral. Anyway, I'm going to give the name I. If it is not given, make sure you put that. E to the power minus ax sin x the whole divided by x dx, and please mark it important. And there is one more question, hence evaluate. What do you mean by the word hence evaluate? Yeah, using this integral, after evaluating this integral, using that answer, use some method and evaluate integral 0 to infinity sin x by x dx. For the time being, let's forget about this. Okay. So, the first thing, I'm sure you watched the videos in improper integrals. In case you didn't watch the videos in improper integral, pause this video right now and watch them, because without learning improper integrals properly, you will not be able to solve these problems successfully. Anyway, I'm going to give two formulae. First is e to the power ax cos bx. We discussed the same thing long back when we learned improper integrals. And the formula is very simple, e power ax by a square plus b square. And I gave you one shortcut at that time. You have to think kind of like in a diagonal manner. So we get a cos bx plus b sin bx, and of course plus constant, and integral e power ax sin bx. So same trick, I told you the trick long back. So a square plus b square, and then a sin bx minus b cos bx plus c. So this is the most important thing to work out the problem. And the second thing is the value of sin infinity and cos infinity. I'll strongly recommend you go through the videos in improper integral, because we learned this properly. Anyway, sin infinity or cos infinity, they are both finite numbers. What are they? Finite numbers. And because of the graph, we know that the numbers lie between -1 and 1. So remember, 0 into sin infinity is not an indeterminate form. It will be equal to 0, because this is 0 into a finite number. Same logic holds for cos. With that information, let's start. So the variable is x, parameter is a, and for your benefit, I'm going to write this integral as 0 to infinity. I hope you don't mind. I'm going to write sin x by x, and then I'm going to write e power minus ax, and then our dx. Look at this. Once more I'm telling you, the variable of integration is x and the parameter is a. But when we apply Leibniz rule, we differentiate partially, and we differentiate partially with respect to the parameter. That is, in this step, when we perform differentiation, the parameter will be the only variable, or in other words, x is a constant, so the whole thing is a constant. So the derivative will be minus x e power minus ax, and then of course our dx. So I hope you're okay with this part. Now simplify a little bit of cleaning up. So this negative will go outside, x and x will get cancelled. So I'm going to write that a little bit neatly, di by dA equal to, so this negative goes outside. Now I don't want to waste your time. In yesterday's video, in lesson number 22, we learned how to deal with improper integrals. You can write that here itself, because the next time you can save a lot of time. So write improper integral type 1. Isn't it type 1? Yeah. Okay, so let's write limit t tends to infinity, integral 0 to t, e to the power minus ax sin x dx. Okay, I'll give you a glimpse of the formula so that you're able to integrate easily. So here we go, we have the formula. And we have a and b being minus a and 1. So let's apply the formula. Limit t tends to infinity, e to the power minus ax, the whole divided by minus a the whole square plus 1 square, and curly brackets, minus a sin x minus 1 into cos x. Within the limits, x is equal to 0 to t. It's better to specify the variable of integration, and that gives me, okay, this is a constant. So I'm going to keep that 1 by a square plus 1 outside, and I can see that there is minus common here. I'll keep that outside. So the remaining part is limit t tends to infinity, e to the power minus ax. I'll repeat once more. I took this minus outside. So now this is going to be positive a sin x plus cos x. Please mind the brackets. Now time to plug in the values, upper limit and lower limit. So we have, okay, so this becomes positive. I saw that negative here, so this becomes positive. So we get di by dA is equal to 1 by a square plus 1, and then limit t tends to infinity. Time to plug in upper limit, e power minus at, a sin t plus cos t, minus time to plug in lower limit. You remember the hockey stick bat, right? Hockey bat. So e power 0 is 1, and sin 0 is 0, and cos 0 is 1. So time to draw the hockey bat. E power minus infinity is 0, e power 0 is 1, and e power infinity is infinity. So this becomes 0. And cos infinity and sin infinity are finite numbers. So this is a finite number, and 0 into finite number will be 0. So we end up with something like this, di by dA equal to 1 by a square plus 1. The first term becomes 0 and the second term becomes minus 1. So di by dA is equal to minus 1 by a square plus 1. So time to ask the question. We had been learning this from lesson 21, and the question is, what are we trying to find? And the answer, of course, is we are trying to find capital I, the value of capital I. And second question, what did you find? We found di by dA. Not to worry, make it variable separable. So we get, it's the same thing, I just allowed to write 1 plus a square dA, and get ready to integrate. So we get I is equal to, by the way, what is the derivative of tan inverse x? 1 by 1 plus x square. Look at this. You can access to formulae, trigonometric formulae, differentiation formulae in my website. Just log on to www.sjmathtube.com and you'll find a special section called formulae. Click and you'll be able to find the formulae for derivatives and integration. Anyway, this tells me integral of 1 by 1 plus x square is tan inverse x. So this becomes minus tan inverse a plus c. And that will be equation number 1. Why aren't we happy with the answer? Because a definite integral can never have plus c. So time for the box. Okay, and in the box you write the question. And what was that? I forgot. Yeah. So we have integral 0 to infinity e power minus ax sin x the whole divided by x dx. And then I check, okay, I differentiated it with respect to a. So I'm going to ask a question by putting a equal to dash, I should be equal to 0. So can you guess that answer? Anyone? Come on, remember the hockey bat. E power minus infinity is 0, e power 0 is 1 and e power infinity is infinity. So what should I keep instead of a? Yeah, excellent. We can keep a as infinity. So now I am going to use equation 1. So instead of a, I have to plug in infinity. And I know tan inverse infinity tends to pi by 2. And instead of I have to plug in 0. So we get 0 is equal to minus pi by 2 plus c. Therefore, c is equal to pi by 2. Time to close the box. Therefore, by 1, we get I is equal to, so tell me, by 1 we got, yeah, minus tan inverse a plus pi by 2. Okay. So, that is I is equal to pi by 2 minus tan inverse a. Wait a minute, I have to do something here. I'll do that a little bit later. Yeah. Okay, now do you remember there were two questions. In the beginning, I'll show you the question. Evaluate this. Okay, we have already done that. If you want, I'll make it very clear. I is this. So I'll write, yeah, we have evaluated the integral 0 to infinity e power minus ax, because I means this, sin x by x dx is equal to pi by 2 minus tan inverse a. Okay, done. Job 1. Okay, now I'll look at the question. So we already evaluated this. Hence evaluate this. Hence evaluate. Okay, I think now you can read clearly. So tell me, what's the connection between the given question, the one which we solved just now, and this integral? Okay, it's obvious. We have to avoid this character. This character is not there. And that happens when a equal to 0. As simple as that. If you plug in a equal to 0 here, you get this, because e power 0 is 1 and the remaining part is sin x by x. So the second part is just one line. So I'm going to put a equal to 0 in the above integral. So we get integral sin x by x dx is equal to tan inverse 0 is 0. So the answer is pi by 2. So it's just one line. Okay, by the way, I'm not that happy with this answer. Do you know in class 11 or when you learn trigonometric inverse, you learn some awesome formulae like sin inverse x plus cos inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. And sec inverse x plus cosec inverse x is equal to pi by 2. It's awesome because it's very easy to study. And remember, in trigonometry we have functions and co-functions. Co-function means you just add a co and you get the co-function. Or if you cut this co, you get the co-function. So sine and cosine are co-functions. Tangent and cotangent means tan and cot. They are also co-functions. Sec, of course, and cosec are co-functions. So that gives me a better answer. So tell me, what is pi by 2 minus cot inverse or pi by 2 minus tan inverse? The answer is cot inverse A. Anyway, let's move on to the next question. Okay, please mark it. Very important. And the question goes like this. Evaluate the integral 0 to infinity sin bx the whole divided by x dx. Okay, now look at this. I'm going to call the given integral as I. And I can see that the variable is x and the parameter is b. And for your advantage, I'll show you something. That is, the given integral is 0 to infinity 1 by x sin bx. If I differentiate with respect to b, as you expect, as many of you will expect in the exam, I'm repeating, this is a very important question in the sense, if you are doing it for the first time, the chance of success in solving this problem is very thin, very lean. Okay, anyway, I'm sure if you are solving it for the first time, you may even plan to differentiate with respect to b. And when you differentiate with respect to b, this will be a constant because b will be the only variable. And you end up with sine, the derivative is cos, and b is the variable, so you'll get times. Okay, so basically you will reach a stage where you cannot integrate. Because look at this, you can integrate this, cos will give you the integral sine, and when you plug in the value sine infinity, look at that, that is where the troubles start. We know sine infinity is a finite number, and we know that sine infinity is somewhere between -1 and 1, but no one knows the exact value. For example, if someone asks me what is tan inverse infinity, I can give the answer, it tends to pi by 2. But if you ask what is sine infinity or cos infinity, all I can say is it is a finite number. And even I can say it is between -1 and 1. But I don't know the exact value. And in other words, it's a total failure. We are not able to solve with this method. And that is why I told you this problem is extra colorful. It's so important. Okay, so what we do is a very small thing, but it's an awesome trick. I'm going to create a new integral, I1. And I create the new integral just because I saw the previous question. What I do is I add a new character, e power minus ax, and I write the question as such. Look at this. I am adding a new thing, that is, I am adding a new character as a product, that is e power minus ax, and I am calling that integral as I1. And my trick is very simple. I am sure that I am able to calculate I1 with the help of Leibniz rule, because this is something like the problem which we did just now. And at the last, I will put a equal to 0, because if I keep a equal to 0, this will become 1 and this will become the original question. Okay, so let's start. So we have I1 is equal to, this is the integral which I created. So 0 to infinity e power minus ax. So this is a key step. Please remember this step. And I think I should keep this sin bx by x. Okay, so time to differentiate. So we have parameters a and b and the variable x. So I'm going to write di1 by dA. And when you use Leibniz rule and differentiate an integral, remember you're going to apply partial differentiation. And that means a will be the only variable when you differentiate. So as always, and I'm sure you understand that step very easily, that will be minus x e power minus ax, and then this is a constant, so we get sin bx by x dx. So x and x will get cancelled. So di1 by dA is equal to, now I'm going to skip a lot of steps. I'm going to write minus limit t tends to integral, because I know it's an improper integral, 0 to t e power minus ax. I hope you're able to follow me. Okay, so now I'll integrate this. Di by dA is equal to minus limit t tends to infinity e power minus ax, the whole divided by a square plus b square minus a sin bx minus b cos bx, where x varies from 0 to t. Now this minus comes outside and there is a minus outside, so it will be positive. So we get di1 by dA is equal to 1 by a square plus b square. And when you plug in the limits, I'm going to leave all those steps for you. You do it yourself. And after some time, if your answer is correct, you will get minus b by a square plus b square. So check whether you're getting the right answer or not. And as always, I ask the question to myself, what am I trying to find? I1. And what did I find? di1 by dA. And that gives me an idea, variable separable, by a square plus b square dA, and then integrate. Now look at this, the variable of integration is a. That means this minus b goes outside. So we end up with di1 is equal to minus b integral 1 by a square plus b square dA. Okay, I'm going to ask one question. What is integral 1 by 1 square plus x square? Of course, you'll give me the answer, tan inverse x. What is integral 1 by constant square plus x square? That is 1 by a tan inverse x by a. Okay, I want you to look at this format. A stands for constant and x is the variable of integration. So let's write the next line like this. Integral is equal to minus b integral 1 by b square plus a square dA, so that it looks exactly like this. Anyway, cutting down the story, we get minus b 1 by b tan inverse a by b plus c. Okay, now time to find the c. Call it equation 1 and you can draw your box. Write I1. I1 is something which we created, e power minus ax sin bx by x dx. We differentiated with respect to a. So I ask myself, putting a is equal to what makes the integral I1 vanish? And the answer is simple. I had to put a is equal to infinity. I had to make a tend to infinity. and I plug in all those values, so I get 0 is equal to tan inverse infinity, which is 90 degree or pi by 2. So that gives me C is equal to pi by 2. So I plug in all these values in I1. So we get I1 is equal to minus tan inverse A by B plus pi by 2. And I gave you a trick earlier. Tan inverse x plus cot inverse x is equal to pi by 2. So this I1 becomes, okay, what happens here? It becomes cot inverse A by B. But what is I1? I1 is integral 0 to infinity e power ax. I told you we created this integral by x dx is equal to cot inverse A by B. Now what to do? Okay, now we are going to avoid this so that I will get I. So the trick is very easy. I put A equal to 0. And when I put A equal to 0, this will become 1. So I get the question sin bx by x is equal to cot inverse 0. Cot inverse 0 is pi by 2, by the way, and that's it. So I'm going to wind up this video right now, and in the next video we will be back with some more very important problems, and I want you to try one question by yourself. I'll give you the hint. The question is integral 0 to infinity cos lambda x the whole divided by x times e power minus ax minus e power minus bx dx. And I will recommend you call it I, so you can write the hint. You find di by dA, and that should be equal to minus integral 0 to infinity e power minus ax cos lambda x. Try it. And after some time, when you simplify, you're supposed to get I is equal to minus 1 by 2 log a square plus lambda square plus c. Okay, try it. If not, we will check out this problem. It's a bit lengthy and it involves a lot of basic things in integration. So I'm going to work out this problem because some of the average and weak students may need a complete solution. So we will work out this problem in the next video. So till then, my friends, bye. And as always, if you like the video, don't forget to share, like and subscribe. So till then, bye my friends.